that maybe you have started the preparation for something that what you can do for this course. Maybe you have to do within few days. Then actually you have to go for your other courses. Okay, and did you go through now transformation? What about others? Have you solved those problems, those three about the transformation?
Yes, sir.
Mantaki Moore said yes. What about others? Uday, what about you?
Sir, I have started transformation, sir. Sir, I was stuck in the color model. I was in a problem of color model. I have solved those, and I have
Okay,
started transformation. By today, it will be completed, sir.
okay, that's good. What about others? Ratul, Redwan, Ratul.
Yes, sir.
What about transformation?
Yes, I have, sir. I am seeing. I have saw your video, sir, yesterday, and I need a little bit more actually.
Okay, Shetuli.
Yes, sir.
Yes. What about transformation? Have you tried?
No,
Not,
sir.
not yet. When do
Yes,
you
sir.
gonna do that? Because you have to start for the other course maybe if you have exam on 18th or 19th somewhere. Minhaj, what about you? Minhaj,
Sir, I have not yet started.
mm, I already told you could be in trouble if you cannot solve it by your own.
But sir, I started the others topic. I will start the math today.
I'm actually emphasizing this chapter again and again. I'm actually telling you, all of you, there has a reason, right? So instantly, if you do some practice about this one, I told you that you should be confident that, okay, I have done some part. And many other chapters, whatever, like color model even, you might have some problem from there can come, but uh, for Viva, actually, you have time to take the preparation for in detail. But some of the problem solving related issue, like algorithm, we had primitives, that line drawing algorithm, circle drawing algorithm. But line drawing algorithm, we have done the assessment, right? Already you have done the assessment. So now actually we have left for that circle drawing algorithm. So that you need to emphasize that one. And for problem solving, I'm actually telling you. And the color model, you have some problem, go through this problem. Also, I told you that you have problems. Some part, maybe a minor part, will be for analytical question that we call theory, and for that maybe you have to take an overall actually preparation. But you can take at the end. But especially the problem solving, whatever the option you have, you need to do it at the very beginning. Okay, and transformation is actually the major part for this case. So that's why I'm just emphasizing all of you, just checking that whether you have actually done or not. If you're not, because there is a possibility, I told you that it could be a unique problem to everyone. So a unique problem, individual basis, if you cannot do it, your friend cannot help you, right? So better you learn actually from there. It's very simple. If you just spend maybe 1 hour, you can actually be confident about the transformation, right? Okay, I hope that you will do accordingly and make a plan of your other courses as well. Then maybe you can do it. Graphics pipeline, we were actually in a position that we discussed up to, I think, this stage processes, right? And we start the application stage, where that application stage is going to be the input, whatever the output for application stage is going to be the input for the geometry stage. And in geometry stage, that we mostly do the work, which are the process maybe we have discussed in here, up to the rasterization, that viewport given for the rasterization phase for the pixel base. Then finally the image is ready for the video controller. Now we have just a quick recap, because these processes are important, that whenever we create the model by application stage, as we know that the model that you are actually creating by using the user data, that we call it actually for world geometry database. As you can see here, those data is actually creating the shape, and that shape is actually a model we consider, and that model we are taking into actually the world space. And whenever we are taking into that in the world space, as you know that their own coordinate of those objects now actually taking in the world space coordinate in respective places, in different places. That is actually the modeling transformation. To move that one, we use actually these transformation functions usually. So that is actually this modeling transformation that we know. According to the coordinate basis, the vertices, that those points, as we can see, we need to actually look out the light sources, about the lighting, what could be the lighting and shading for it, is a different model for the lighting that we have. Then we are checking that from which point we are actually looking at. That is actually we are calling the viewing transformation, and that is actually the z-axis. According to the z-axis, that we can understand that our viewpoint should be. Then we go for projection transformation. Whenever we go for projection transformation, we are creating a volume of our view, and that is actually the ultimately be visible to the camera, or maybe our eye point. It could be two type, perspective or orthogonal or parallel. So perspective is actually according to our the distance of that near plane and far plane. As you can remember that yesterday we have drawn that one, that if your object is actually close to your viewpoint, then it will be look bigger. If it is actually far, then it will look actually smaller. And usually that perspective projection, the angle actually create the wider range as far as it goes, while in orthogonal it goes actually in the parallel form. So the actually near plane, far plane, wherever you are, your object looks actually same size. Then clipping, that actually we need to check in your volume that actually you are creating of your view, according to the viewpoint, that if something from the side that actually, or some portion that is actually outside of the cube, if it is false, then we need to remove it. That's actually the clipping. Then we take that image to viewport in a device, and that device is actually having that height and length and the aspect ratio to check that how actually it will be adjusted, and then actually define the coordinate values according to the pixel actually definition. Okay, this is up to that rasterization process that we have seen. And then in geometry stage, you can see there that after the shading and lighting, that we are giving that to the rasterization stage, but there are also those processes are actually already there after the viewing transformation, okay, the projection and so on. In rasterization stage, mostly the image in the pixel based definition, that the other functions are actually working, that finally to make it ready for actually in your display to actually show. Okay, so we will go for today about these steps here, that in the stages, what are the actually steps they have, or maybe the processes we can say, after the application stage that actually we get. And we consider that one as a scene file actually, that is we are going to actually generate. right? That was actually our main concern. And the scene file is actually having those contents or objects having some interrelationship that we are calling actually their data, our data structure, the relationship with one to another, that will be actually done one by one processes or steps to finally to get this actually image. So scene file is actually our model, that representation that actually we can tell in short. For modeling our shapes at the first that we get from actually our application stage, then we go for that modeling transformation. As you can see here, that this is actually for preparing the shape models or the models for the shapes that designed by different actually this primitives, especially the polygons or the parametric curves like that, or internal surfaces. Okay, and they could be actually in own coordinate systems. And we have seen that whenever we take for that one in model transformation, that objects those put in the scene by applying the these transformation functions, translation, scaling, and rotation, and especially the linear transformation, which we call the homogeneous transformation, is used. Like the objects, whatever the shape and size they have, we actually in linearly actually the transformation function we apply, they will be in respective places only. Okay, according to that. Now, the location of all the vertices are updated by this transformation, so that maybe one of the object you have in multiple number, so that you can actually put them in one place like that. Then we go for actually the viewing transformation, and the viewing to actually projection transformation here. We want to create a picture of the scene viewed from the camera. As you know that the camera is actually our viewpoint. We apply a perspective projection here. We already discussed that one. This is actually the perspective projection. This is the parallel or orthogonal projection, uh, where actually this to convert the 3D coordinates to 2D coordinates of the screen. As you can see here, the objects are all now in outline form, okay, or wireframe form. Those objects have been created with the primitives and then actually taken with the transformation function and in this actually world space. In perspective projection, as you know, that objects far away appear smaller, which is actually far away, and closer objects appear bigger. This is actually indicating that your the angle for the viewing actually angle, that how much angle it gets, the wider angle it gets for perspective projection. Then also another important part is actually hidden surface removal. As you can see here that the objects that we have from our viewpoint, that some of them should not be actually seen, because there is another object is actually obstructing the way of actually the object behind. So that's actually that objects occluded. It says the obstructed by other objects must not be drawn. So hidden surface removal is actually trying to take out those of the part of the object which should not be actually seen. Now this also can be changed, because whenever you create a volume for the view and you move your viewpoint, then some part also should be actually seen. Now that's why you take the model individually. Okay, so you cannot see does not mean that it's not there. Okay, so that's actually as like in the real life. Then go for the shading. Shading is actually we need to decide the color of each pixel, taking into account the object's color, lighting condition, the camera position. Now this is actually we are going to give it for the rasterization phase, and in the rasterization phase we have to think about the each pixel color, as we know. Now for this reason, that's why actually we need to consider actually few of the part, like your light point light source, where actually the light is coming from, then what kind of actually object we have, and that object actually should be actually reflecting the light, as you can see, in different angle, and where is actually your viewpoint position is. So these are actually the conditions that we need to consider for, that's what we call the lighting condition, the camera position, and the object's color as well. That according to that, actually you can see that object. So that's actually part of the shading. There's actually many types of shading, as you know. Shading refers to the process of altering the color of an object surface polygon in the 3D scene based on its angle to lights and its distance from the lights to create a photorealistic effect. So actually, angle of the light is actually important, as you know that the light will be reflected. So if the angle is actually quite as like say like the light source is on the top of this object, so that type of object should be seen in such a way where the light is actually having an angle where it is reflecting a wider angle, if we consider from the top. So then you will see the light in different way. So this angle of this light is actually important. Also the distance of the light, actually that is also a case. Shading is performed during the rendering process by a program called a shader. So you can see that some special program can actually handle this, actually this shading activity. And you can see that this is actually called the flat shading. Okay, the advanced one is actually called a Phong shading. Okay, this one type of shading, as you can see. And it is also from the object you can have some assumption that where actually the light source is, right? You can see this actually the reflection here of the light, so that it is understandable that the light source is actually somewhere maybe on the z-axis, that which is little bit upper part of it. And whenever it is actually the flat shading, you can see that a small rectangular that boxes, those polygons have actually created that angle, created that actually that circle or that ball shape with some depth. It is understandable with some depth. Okay, this one of the shading is constant shading, or it is called the ambient shading, as objects colors by its own color. So that it's whatever the objects you have in your image, that object you have actually taken here from your that what is called the transformation function here. You set out their projection and all these things. You see all of them are now actually defined on their own color, own basic color. And that's the relationship with the light here. That's actually called the constant shading or ambient shading. Okay, then we check for actually the flat or normal shading, that is actually object's color based on its own color and the lighting condition. So earlier it was not actually considered the lighting condition. All of them are look like on their with their own color. Now this one is actually having some kind of lighting condition as well, because a little bit of some darker part, as you can see, so that we are considering that this actually position of the light in this case at least. So understandable, these parts are actually illuminated, some behind parts, so light is definitely somewhere maybe in the z-axis, like this part of it is the flat shading. Then we go for actually Gouraud shading, which is for advanced shading. And still there is actually no specular highlights. There's actually specular highlights related with the light reflection and a lighting calculation for vertex that actually it is doing in here. You can see that the difference between this flat shading and this Gouraud shading, that this is actually getting the shape of your individual objects, that's which were actually using the primitives. Now this shade is actually creating for more smooth of the area that actually all the objects should be. So now at least there were actually, you can see that the triangle shape for this cone, now it is actually more smooth in the round shape. Okay. So lighting, they try to calculate per vertex level now. Okay, so it is more actually precise, as it was earlier taking actually this triangles color. Now it is more like in the vertex level, all the vertices color they have been divided. That's why it becomes smooth. Then the shapes by the polynomial surface with they try to find out specular highlights now has been added. You can see the reflection of the lights, so in a mirror like way that it has been actually reflected. Then the Phong shading, the advanced one that has been actually used with the specular highlights, that means reflection with reflection, and with the advanced shading that actually we can find out like more like what it should be look. Now still there are actually many things are actually left, but this is a position maybe can be taken to the pixel based actually definition for rasterization. As you can see that they will try to find out what are actually the further need to work at this stage, like sampling especially they will think about the texture, what actually that image they had, is there any composition is needed, or maybe work with the color. Then finally it will be ready for actually our scene file that actually what we have seen. Now in rasterizer stage that we can see, that is also implemented in hardware, the convert the vertex information especially into the pixel information, and which is needed by that video controller, because they are going to actually show that in the pixel based device. So pixel values they do output actually finally that color value. Now, in the first part, in the rasterization case, that converts the vertex information output by the geometry pipeline into pixel information needed by the video display. Okay. One of the things they do is actually aliasing. As you know, that aliasing is actually a distortion artifact. So, like what actually you can find whenever we had in the objects earlier with the coordinate basis value, we had a specific shape for the object. Now when we convert that one in actually pixel based information, you can see that they are only that pixel number of pixel that actually we can have. In chapter for geometrical primitives drawing, in that chapter we have seen that that has actually some issue about drawing the line for selecting the best that pixel which should be. So that's why we have used that decision parameter and so many things. Now this is actually an issue for actually when we transfer that actually all these objects as a scene, then actually there is a distortion happens, like for the pixel based definition. So especially if you go for high resolution, then so anti-aliasing is actually from high to low resolution. Sorry, so that whenever you have low resolution, less number of pixel, then actually it come out like a zigzag form, as you can see here, not the smooth one. So anti-aliasing is actually the technique to remove the aliasing, the sampling process basically that we do. You can see that anti-aliasing, like aliasing that polygons, especially in this edges, especially the joint for these edges, like those colors, especially create actually in low resolution that jagged area like that. So that we need to do something to do that actually fine or smooth, as you can see here. It should be like actually this one, and it can happen for this situation when you have actually the definition on the pixel. So that's why we do the sampling process. Sampling process is something that is each pixel that actually can be divided, okay, in this more small part actually in the subpixel level, so that we can create actually a sampling process there. So look at in this one, say like one of the pixel was in there, where actually that both of the color should be actually get, but what actually you are going to do, you are going to do either green or blue. You have taken like this way, that's why it is actually looking this kind of zigzag. Okay, so it is always better because the shape is actually should be like that. So what we can do, we can do actually a average color value. So if we do a sampling, like this is actually a pixel now divided in 16 samples. Okay, so if we have 16 samples, we can identify that how many samples are actually the blue color, how many samples are actually the green color. So out of that, in 16 samples, if we found like 5 of them, okay, this 1, 2, 3, and 4, 5. These 5 they have considered. 5 of them are actually the blue color. The other 11 of them are mostly the green color. So we can compose an average color for this pixel. If we compose an average color of this pixel, then the jag area, it will be look smooth. Okay, it will not actually look like that. It is as like this jagging. Okay, that like not a smooth area, that it should not be like that. So if you actually the edge area, that if you just do this sampling process and get the average color, then it will be look smooth. Okay, that's actually the anti-aliasing technique, or we can call it a rasterization in the sampling process. Okay, then the texture mapping. We have seen the texture mapping is actually method or technique for adding the detail in the surface texture that actually you have, like especially in the raster image, what actually you have in your object, like this one, say like this one or this one, all of them object that we have actually done up to that point, after functioning, none of them had any of the surface that what they should be. We were actually defining that vertex level, that color up to that, and here actually we have done in anti-aliasing that part, that we have some problem in that vertex level color in the, sorry, that converted in the pixel level. Now what actually that should be, that we have identified. Now we go for what actually in the body it should be, for that two-dimensional objects that you are, sorry, the two-dimensional that surface that actually you are going to create, and that will be put down on the three-dimensional actually objects, that means wrapping around. So the 3D objects acquire surface structure similar to the 2D surface, as like this one, a cone, a cylinder, that as you can see. So we can create actually a two-dimensional object of that wrapping that one on the body of it. Okay, why it is has to be like that? Because if you change the viewpoint, so that actually you can see some hidden part as well in later on. So that's why every object will get some kind of a wrapper on the body, that's actually the texture mapping. Also you can see here that you can go for in the pixel based, even with the coordinates, that again for putting what are the on the body, it should be like this. Rex is actually having that individually that point out that what actually it should be in the body. Now this is not related with the construction of these objects, rather than on the top of the object, that what actually you can have as your the two-dimensional wrapper that you are going to do for the texture. Okay, then it is more like working with the light now. As you can see, is one of the point is global illumination. It can happen. It can happen like the indirect lighting. Actually, any image, if you want to work that a finer one, then these are the actually advanced work. You need to find out the indirect lighting as well, that what it can be. That indirect lighting process, are some of them are called like light bouncing or color bleeding. Okay, so light bouncing or color bleeding happens how? Like for example, this image, as you can see here that if you look at the image below closely, you will notice that the green color of the wall. Okay, so the wall is actually green color. Actually, the wall is not actually green color. From this perspective here, you can understand this is maybe a red color, that wall, but this side the wall is still maybe the white color, but there is maybe a light source which is actually the green color. Okay, and that light is actually reflecting on the objects in such a way that it looks like more like a green. So the objects here is a small sphere here, that some part which is actually white one, that is actually reflecting that light. So this is actually the light is bouncing here, and you can feel that this is mostly you also need to, in your image, that you also need to actually define that where actually the light can be bounced. The object is also important. You can see that if they're transparent, then you can see in between actually that objects. Like this is actually a transparent one, but still it is actually reflecting that the surface. Also, actually, maybe there are other balls in here. It should be, maybe it could be, they look like. So this is the global illumination. As you can see, the globally, the light source, there's a one of the light source on the top there, as you can see, but there are some of the light source that we have, which is actually, maybe it's not visible here, but the light is actually bouncing actually to object, and that's why the color is actually also have some bleeding. Like this one as well, as you can see, this is the light source, so the transparent one. You can see that the light is actually falls through that object, and it looks like the light source in the down there. Actually it is not. And this one, a marble stone, that statue, as you know, that I have seen in Taj Mahal actually, that whenever you have those big stones, they automatically light the transfer. Like one point of a big stone, that one point in the design, that actually you put the light with your torch, and there is actually some pigment ink they have brought, maybe from Europe by that time, which actually take the light and transform. So one design of those actually flower and so many things, they illuminate automatically. They get the light in one point and they start illuminate on the all the part. So it's a very interesting one. Like you can see here, the light is actually falling maybe somewhere in the front, so that part of the object that behind is also illuminated. The light has been transferred with that. Okay, so this is actually that light bouncing and color bleeding that happens in the global illumination. That image composition that we have seen, another one, this is very common work for the actually visual, that animation, or maybe if you think about the visual effect that we do understand, the compositing or combining the visual elements from different sources in a single image. Finally you create a single image, that is actually called the composition, and often to create the illusion that all the elements are parts of the same scene. This is the interesting part, because whenever you create some virtual image with your own imagination, then actually definitely the model you have created, you are having another image for background, you are just joining that one, or maybe a few number of the images that you actually create and put down in one place, so that it looks like a one environment or one scene only. That is the composition. In computer graphics, alpha composition is the process of combining an image with background, okay, to create the appearance of partial or full transparency. Now, it is often useful to render image elements in separate passes. Okay, so different phases maybe you can do, not in one page, and then combine the resulting multiple 2D images into single image. Now, so you can understand that one of the process like image composition also have a different software and also different phases of it to finally complete that one. Okay, like this is a very good example of image composition, and this is actually, anyone have any idea?
Galaxy, sir.
And definitely galaxy, part of the galaxy this could be. And because you you know that the galaxy has a specific shape. So what about our galaxy? Do you know our galaxy about
So the shape.
shape, name?
No, sir, forgot.
Okay, our galaxy name is the Milky Way. Okay, and the shape is, it's actually kind of a spiral galaxy, but it is not that much spiral, rather than it's kind of a moving like this way, the circular formation. And there is another galaxy, very close one. Our neighbor galaxy is Andromeda, as it is said that at some point two of these galaxies will have a collision. Okay. The way it is spinning, as you know that our solar system is actually spinning this area for a few millions years maybe. So or maybe some more years. Actually, I don't know that data. Now this is actually the center of the galaxy. You know that our solar system is not in the center point, it is actually in the outer edge. So in the center point is very heavy. There are many number of millions of stars, as you can see, and there are actually many number of this what is called the solar system. There have millions solar systems. So that's actually light travel to there actually takes also millions of years. So we have no very good idea about those of our galaxy central part. Okay, but it is actually can be seen, especially in the very early morning time, that some part of the center can be seen. So you can see like some of the images. Maybe if you search that some of the images internet, you will get like in that this vertical that shape like this way. There is actually shape can be seen of millions of stars and condensed. They are actually condensed. Like these parts are actually condensed. There also have some galactic clouds. Anyway, this is actually a real image of our central of our galaxy, and that is not a single image. That is actually the thing. That's why we said like this is about the composition, the image composition or alpha composition that can be created. Now, three famous actually the space telescopes that actually we have in humankind so far. Those three of that space telescope tried to take the image of the center of our galaxy, and then they actually put down in one place, and they put down in such a way that they can create this image. So they had to actually work on it. Now those three actually those space telescopes are actually Hubble, we all know, which is the a very famous space telescope, which will be out of actually work very soon, maybe next year, because we are going to send actually the most advanced telescope this year at the end of this year now. That Spitzer telescope that you will find in maybe in December, that is going to send. Now that Hubble telescope, the Spitzer space telescope, and Chandra X-ray observatory, the three those telescope, they have actually taken these images of the center, and then they actually do the composition. So the composition, that means actually from some angle that some of the objects were best seen, then maybe another one is actually best seen. So then they actually put down, and with those many phases that has been actually says like you have to go for different separate phases and combine that the result. Okay, so that actually then finally you have seen the center of the Milky Way galaxy, that where maybe millions, thousands of this planet like Earth also can be possible to have. Okay, so that's about the composition, image composition. Then finally the color quantization. That if we go for these rasterization phases, as you can see that this composition, then the color quantization, that means actually tuning the color. That if you have some actually color some part, you need to reduce to see it actually as like in the original image or the real life image. As you can see that whenever we apply the colors actually whatever in the object, say like this is an object, the basic color whatever we have cannot be seen everywhere at the same. Now that will be actually definitely we will have according to the light and shade that the color should be changed. So that is actually the color quantization or color image quantization, that reduces the number of distinct colors used in an image. Okay, and the main intention of this quantization is the new image should be as visually similar. That means look like as same like in the original image, as like this one, this first one, as you can see the image is actually after getting the quantization as like what we can see the extreme point of the colors according to the light. Okay, All right, so that's about the pipelining process, the three of the stages. These are some of the definition of small dose terminology, as you can see. So these three of the stages with many number of processes are actually basically this chapter is important for your Viva. Okay, that I can tell you. Your understanding about this process, this processes individually, that what could be the projection transformation, what do you understand about that orthogonal projection, how it is different from actually the perspective projection. So this could be important for your actually Viva thing. And I try to actually cover this one as much as possible or have some discussion, because whenever you go for your further work or study, pipelining, these rendering techniques are actually important, these ideas are actually important, because for this individual process to work, there are also algorithm, there are software, how they can work. Those who work actually in the graphics media, those professional body, they have those actually different software to work on the editing the image or maybe the visual effect. So these three stages that we try to actually explain those processes mostly. All right, again, I have already mentioned that these are actually, as it is conceptual based, so it is a good candidate for the Viva exam, not the written exam. Okay. But still you keep in mind, because in the written exam maybe you can have like a short question, there are chances to have a short question, so any short question also there could have something, but whatever it will come in your short question will be the conceptual base. So not any specific answer that you can find from the slide, but rather than actually if you understand you can actually answer it. Okay. Any question, any there? Yes, mostly the review class, but it's still, I will discuss something about clipping, okay? Which I'm not telling that you will have in your written exam. I know that you will not do it, but this is also some idea to give, because this is also important part. As you can see that in the process of in here, that one of the part is actually clipping. So in the viewing volume, at least you you have actually done some modeling transformation, the transformation activity. We have seen that how the object can be drawn, right? If you just think about complete graphics, actually the discussion, and then the rasterization phase, actually those work like texture mapping, they also have some actually algorithm. Also if we go for viewport transformation, then the aspect ratio, that discussion, hidden surface removal is not in here, that is also have some algorithm. So advanced computer graphics, you have those actually the thing. Now at least I discussed something about clipping, say like it for even 20 minutes, that will give you some idea. I'm not telling that I will do the assessment for it, but at least you will get some idea about it, and it could be necessary at some point. Okay. But already I have actually told you that for your written exam, what could be the possible actually your preparation should be. For Viva, it is difficult to say, because more or less your understanding should be about the topics that we have discussed. Yes, Didar?
No, sir, nothing else, sir.
Okay. So that's about the graphics pipeline. So I think I have not uploaded this one, maybe, right?
Yes, sir.
I think I'll upload everything by today. And about the clipping, as I have said, I think just some general discussion about the clipping for, I think 5 minutes we have, 5 to 10 minutes. Yes, 5 minutes we have. Just for clipping, clipping is common actually thing for everyone that we know, because that is actually also we call it cropping. How do we crop this image? So like we have this image, how we can actually cut this image, right? That the part, some of the part will be cut. You see that this is always done with a window, right? We actually draw a window with our mouse to tell that this part of the actually image will be retained and this other part will be actually removed. So for all the software actually work like this way. Now the software of those window, how they work, that is actually the clipping idea, that how actually that window can be worked. Okay, so as you can see that according to the coordinate, the system that we define that box, or we call it window, and then only actually the inside the window part that should be retained, the outside the window part will be actually taken off. So that we will see tomorrow in the next class. I will take only maybe 10-20 minutes. I'll give you some resources as well, so that maybe for your further study if you want to go. And also I expect that you take a little bit preparation by this time, that what is going on, and have some question, any relevant question that you have on the as a review that you are saying in the next class, so that I can actually try to help you, give you the information that actually you are looking for. Do you understand?
Yes, sir.
Without actually having some kind of idea, you cannot ask question actually, because you don't know what is the problem or what actually is the necessary information you need. So that's why you spend some time actually, some time, and then try to have some idea that okay, this is maybe I am not very good, or maybe is there will be a question from there, or maybe what should be, or how I can take preparation, or maybe I have taken the preparation like this, so is it actually okay or not, or maybe for Viva, because without the Viva, that would be the last class, maybe the next one. So if you have any query, because you don't write to like maybe in the classroom, if you have some, anything to know, so better you ask on the next class, or also if you have some query, you can write in the or use in the classroom space. Okay,